Yeah. So thank you for having me here and giving me an opportunity to discuss these things. So what I'm talking about is the near perfect Broadband absorbers for solar energy devices. Just have a quick view of where we are located. So about 40 kilometers from Chandigarh and around 300 kilometers from Delhi to the north. That's where the Ropar is, and we are look. Our campus is near River Satluj, so it's a very beautiful campus. Maybe some of you might like to visit sometime, and we'll be very happy to host you. This is campus at night, so it's yeah, we like it a lot. These are okay. So the invention we are going to discuss today is about the textured nanocomposite coating composition for absorption of electromagnetic waves. So the motivation for this work comes from like following issues which basically hampers the application of existing absorbers. Like most of the absorbers which you see in your panels or solar heaters, they work efficiently in a visible range, which means that the solar spectrum we are getting from the sun, so significant part of that goes unutilized, like IR and UV we don't use for conversion. And that is one of the reasons that why we have very low inversion efficiency of these solar energy based devices. Another thing which you might have noticed that all these solar panels are flat. So basically, they are basically rigid. They are all mounted on the rigid substrate, which is like you cannot bend them, and that becomes a problem when you have a non-planar surfaces. Like if I want to have an absorber on, let's say, airplane fuselage or wing or some other thing, so those things these cannot be used efficiently. And then of course the maintenance of the absorbers. So for example, in the colder regions, the solar panel has to be cleaned very frequently, and that becomes a huge maintenance cost. So this explanation basically is an effort to address some of these issues, which we are trying to see here. And what we are a strategy we are following is the texture. So if you look at peacock, like you see what the color of the very nice peacock is because of this texture. So the application is comes in the solar PV panels and solar heaters. So what we have first started with the rigid absorbers basically because that's what easy to handle, and then we have made some optically graded material which basically in refractive index is increasing to in the direction of the incident beam. And what it does basically it bends the beam inside, and then when it is reflected from the rigid substrate, it goes back, and at that time it basically create total internal reflection effect. And because of that, and of course, we have optimized the texture geometry, which is basically 55 degree this angle, and the height and the width of this. So they are basically optimized numbers. We have optimized these cones so that we can get the maximum absorption or maximum scattering of the incident beam. And what it does is basically, if you look at here, so it absorbs around more than 99% of light in the whole range UV visible I and up to NIR, which is to 2000 nanometer. And this is published in those papers. And here, so this is the effect why we are able to do that is basically bend angle and total internal reflection and multiple scattering, and together they contribute in the absorption of the whole incident beam. Second thing is, like I was talking about the maintenance, and then we saw that if you have these absorbers, the surface makes a water contact angle which is around 162 degree, so kind of a lotus effect. So which means if water comes on these panels, it will just roll down, and with that it will also take away the dust particles, so it will clean automatically. You don't have to apply certain person on that. And then basically this is exactly invention as an extension of this technology, because that was on the rigid surface, we basically put it on the flexible substrate, so that I can mount it on anybody, any surface, whether it's made of steel, composite, plastics, or anything. So there basically we have used PDM as filler, and then we have optimized again the texture, which you see here in the nice images, and the effect of that you see here. So we have the untexture. If you don't do texturing, then of course it's a bit cost effective as compared to texturing, because that's pretty much adds a lot of cost in that. So if you don't do texturing, 96% absorption in the whole UV vis IR range, which is not bad. And if you do a texturing, you'll get at least 3% increment. So for industrial application, both, I think this will be more like where cost is not a problem, but here, like for low cost applications, we can also focus on untextured composite. So this is what is all invention about. Then we have developed a bit more testing with the different kinds of surfaces, like made of metals, plastics, and glass, and it shows very nice adhesion strength, which means it can be mounted on different types of surfaces which are made of different materials. So this also published in one of the journals, and then you can see that we can just fold it in any form. So you can just, fold it, put it in your pocket and spread it. It won't deform at all. And in that sequence, we also developed some really, I think, near perfect absorption, like perfect like blackbody. So these are basically very novel form of carbon, which is called flower carbon nanotubes, and they mimic like a dandelion kind of flowery structure. So you have this flower, which is the stem, and together, if you put them, lots of them, then basically what you see is something like this. So you can absorb 99.98%. And you see that this is the independent of incident angle. So 99.97, 99.98. So what does it say is that even if your sun, when sun is moving from the morning to evening, the incident angle will change, but your absorption capacity will not change. And it has a emissivity of close to 0.98, which is near perfect, and the contact angle of 172 degree, which means it is just like a lotus surface, which means dust and water will not stay there. So you can just clean it as per your, you don't have to actually do too much of periodic cleaning, and that will save a lot of money. So we're working on these some other things where we are synthesizing carbon materials from walnut shell waste, and then we are also using waste rubber from tire industry to make some structural composite. Maybe Shashank will be interested in that. And yeah, so this is like we are now making solar heaters and see how much efficiency we can improve with these black paint or the material which you've developed. And also, of course, I'm looking for right collaboration to upscale this technology for the mass production. Yeah, so I'll welcome any collaboration from this. These are some facilities which we have our lab. Yeah, and thank you for the attention.